Professor Belton. This is Trigonometry Chapter 2, Section 1, Graphs of Sine and Cosine Functions. This is Part 1 of 3. So to make the graph, we'll first make an XY table, and we'll use the unit circle as reference to get our X and Y values. So, okay, first, 0 degrees, sine of 0 is 0, so get a point at 0, 0. Next one, y equals sine of pi over 6, and we get 1/2. So at pi over 6, we get 1/2. Pi over 6, 1/2. Next value, pi over 4, y of sine pi over 4 is root 2 over 2. So at pi over 4, I am root 2 over 2. We'll pause there on that one. And y equals sine of pi over 3. That's going to be root 3 over 2. So pi over 3 is a root 3 over 2. And these are both going to be decimal values, of course. So root 2 over 2 and root 3 over 2. Those are approximately 0.71 and 0.87. Okay, so if we go to the pi over 4, we'll go to about approximately 0.71. And the next one is pi over 3. That could be 0.87. And our next one, pi over 2, y equals sine of pi over 2. We get the 1. So pi over 2, we get a 1. Okay, so that is the first graph from 0 to 90 degrees. Okay, and of course sine is positive in that quadrant. And if we look in the next quadrant, it's the negative positive quadrant. Sine is positive in that quadrant, and the answers repeat as we go around. So the next one, y equals sine of 2 pi over 3. Now we're back to the root 3 over 2. And then the next one is 3 pi over 4. We're back to the root 2 over 2. Then we're back to the 1/2. And then finally we're down to 0 again. So it repeats itself when we get all the way back down to pi. So look at down to pi. We're back to 0. And we can put those values onto here symmetrically. And we get our first half a cycle of pi. So from 0 to 180, or pi, it's positive. And we notice when we get down to here, now it repeats itself, but now they're all negative, because this is the negative negative quadrant and the positive negative quadrant. So you can keep filling out the table as you go, but now they just become negative answers. Okay, so we can fill these in. 2 pi over 3, root 3 over 2. Let's see, what's the next one here? 3 pi over 4, and root 2 over 2, and 5 pi over 6, comma 1/2. And the last one, of course, is 6/6 or pi, which is going to be the 0. So we're going to end at 2 pi. 2 pi and 0 are the same. And at 3 pi over 2, we're going to be at negative 1. And you can approximate the other points. So what we're noticing here is we don't actually need to do every single point on the unit circle. Obviously there are more than just the 30, 60, 90, 45s, but what we're seeing is even this many is way too many. You do not need to fill in the complete table. So going by twelfths is too much. We can reduce this work down. So if we look at it in terms of a 1/6 graph, we can eliminate it down to the values that are in fact 0, and 1 and 1/2. So basically sine is 0 to start with and 0 to end with, because this is both 0 and 2 pi. Okay, at pi itself it's at 0, and then halfway between at 3 pi over 2 it's at negative 1, And at pi over 2, it's a positive 1. And you can do the halves in between, so the halves in between are the pi over 6 is a half, and the 2 pi over 3 is going to be, I'm sorry, wrong one, 5 pi over 6 is a half. And the next ones, we're going to be a negative a half and a negative 1/2 at the 7 pi over 6 and the 11 pi over 6. So now we get a sinusoidal curve. We used less points that time. And now if we even get rid of the halves, we can even do less than that. So we just look at what the quadrantals would be. So looking at just the quadrantals, an even simpler way to do this is just to do the 0, 90, pi, which is 180, 270, and 360. So we have 0, 0, and 0 for 0, pi, and 3, and 2 pi. And then halfway in between, at the pi over 2 and 3 pi over 2, we're at 1 and negative 1. So we're at 1 and negative 1. And we get 1 cycle. And of course this keeps going on forever because sine repeats itself as you go around the unit circle many times, forwards and backwards, clockwise and counterclockwise. Okay, so that's a standard sine graph. Let's go to a standard cosine graph now on the next page. Pause the video, try it for yourself. Okay, so for the cosine, we do the same thing. Cosine of 0 is going to be a 1, so I get a coordinate of 0, 1. Okay, let's move the unit circle out of the way here. We'll move it down, right down to there. Okay, so now the first value is cosine, and we're at our 1. So 1 and 1. Okay, now we have y equals cosine of pi over 6, which is our root 3 over 2. So pi over 6, root 3 over 2 is the next coordinate. And y equals cosine of pi over 4. So that's root 2 over 2. So you have pi over 4, comma, root 2 over 2. And next one, y equals cosine pi over 3, which is 1/2. So pi over 3 is 1/2. And the next one, y equals cosine of pi over 2, is going to be 0. Pi over 2 gives me 0. Okay, so that is the first quadrant from 0 to 90 degrees, or pi over 2. If you look at the degrees or radians, so we can graph that on the graph. And again, we probably don't need all of these. We could put them on there though. So it's 0 or 1, and then pi over 2, I'm at 0. So in between, at the pi over 3, I'm at a half. Okay. Let's see here. And pi over 6, I'm at root 3 over 2. And pi over 4, I'm at root 2 over 2. So I have a graph that kind of looks like that. So that's my first one. Then the next quadrant, it's going to be negative, positive. So now my cosine is going to be negative. And then I get down to the next quadrant, negative, negative. My cosine's negative again. And then I end with negative, positive. I'm sorry, positive, negative. So it's going to end positive. Okay, so it repeats itself, but now we're going to be negative. So we have y equals cosine of pi over 2. I'm sorry, 2 pi over 3. That's going to be the negative 1/2. So 2 pi over 3 is negative 1/2. And then we have y equals cosine 3 pi over 4. That's going to be the negative root 2 over 2. So 3 pi over 4 is negative root 2 over 2. And the next one, y equals cosine 5 pi over 6. That's going to be, excuse me, the negative root 3 over 2. So I have 5 pi over 6, negative root 3 over 2. And of course pi, cosine of pi is negative 1, so at pi we're at negative 1. Okay, so we can do the pi negative 1 right there. You can fill in the other points in between if you'd like to, but you get the idea. Okay, so we have positive in the first quadrant, we have negative in the next quadrant, and then repeats itself negative, so it's going to go back up. So we get to 3 pi over 2 over here. That's our break point back to 0, so 3 pi over 2 is going to get back to 0. And then the last quadrant is going to be a positive, so it's going to make it back up to 1. We get a single cycle of cosine. Okay, but again, we don't need to do all of these points. We did more points we needed to here. We can break it down. So let's skip down all the way to the pi over 4. We don't need them all. So we just did the quadrantal angles. We can get our cosine. So our quadrantals, we start with 1. And your pi over 2 is 0. And your pi is negative 1. We're back to 0 at 3 pi over 2. And then cosine, again, it's going to be 1 when we get back to 2 pi. And you can fill the ones in between if you want to, but you don't need to. So that is a single cycle of cosine. But again, you can go continually clockwise, or you can go continually counterclockwise, and these cycles will repeat, so it makes waves. So let's go to the summation at the end. Okay, so what we found was, using the unit circle, okay, the sine starts at 0 and ends at 0, and halfway between is at 0. And again, you can do your unit circle to remind yourself about the coordinates: 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, and one time around is 2 pi all the way around. So halfway in between here, we're at 1. And halfway in between here, we're at negative 1. So that is a single cycle, what's called a period of pi. Like a period is 45 minutes in our class day. Okay, it's 2 pi here for one period. Alright, but the domain was left and right. This goes forever to the left and forever to the right. And the parentheses mean it can't reach it, because you cannot reach infinity. So this will repeat itself. So every pi, you're going to have zeros. And then every half, you're going to have your negative 1s and positive 1s, negative 1s and positive 1s. So you can go clockwise, or you can go counterclockwise in the unit circle and repeat these cycles and get your sine wave that keeps going. So the highest value is going to be 1, and the lowest value will be negative 1. So that is the range. And you put the brackets because those values aren't included. You can get to negative 1 and 1. So if you look at the intercepts, they're every whole value of pi. So 1 pi, 2 pi, 3 pi, 4 pi, negative 1 pi, negative 2 pi, negative 3 pi, negative 4 pi. So basically, the x-intercepts are n pi, comma 0, where n is any integer. Okay, so that's the basis for the sine. Now let's do the cosine. So again, remembering the unit circle if need be. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And of course the first value this time is the cosine. So the cosine starts at 1. So at 0 we're at 1. And at pi we're at negative 1. And we're at 2 pi, we're back to 1. And halfway in between we are at 0 and 0 for the half values of pi. So these make the initial cycle, or one period of cosine. So that is 2 pi for one period of it. And again, it's going to go forever to the left and forever to the right, because you can go forever, right? So every half pi it's going to hit 0. And it's going to reciprocate between negative 1 and 1 continually, not going above them. So negative 1 to 1 is the range, which has a closed box because you can be those exact values. So let's go put our intercepts on here now. Negative 1, 1, negative 1, 1, okay. And again, this time they're the half values, so it's n pi over 2 comma 0. But you notice there are 1 half pi, 3 halves pi, 5 halves pi, 7 halves pi. Those are just the odd numbers, aren't they? So where n is any odd integer is the case here. Alright, that is the end of part 1.